This is a quick solution to the first problem on the review problems for integration, where the problems are asking about using geometry to evaluate the integral. And the idea here is to remind you that the definite integral can be interpreted in terms of area between a curve and the x-axis. So if we're going to use geometry to evaluate the integral, that means we need to draw a picture of the curve that we're integrating and try to understand how it's made up of shapes for which we know the area formulas from geometry. So in this case, the function is the square root of 32 minus 4x minus x squared. And so we need a picture of it. We could use Mathematica, as we were doing in class. This is the plot command using the square root of 32 minus 4x minus x squared over the range given. You'll notice I put in minus 10 to 6 in order to make sure I have the whole thing there, but the integral itself is, in the problem, says to integrate from negative 8 to 4. And this region lies completely above the x-axis, so the value of the integral is just the area of the picture. So the integral of this curve, which is the semicircle, is the area is the integral from negative 8 to 4. Well, I'm sorry, the integral from negative 8 to 4 of that curve is just the area of the semicircle. And we know the formula for the area of a circle, so we could take the area of a circle and cut it in half, and that would be the area of the semicircle. If you haven't set up Mathematica yet, this is what the one I'm showing you here is what the online version looks like. So remember, there's a link on the syllabus that tells you how you can activate an account for Mathematica for free. It's all paid for by the state system. Or you could just Google the word Mathematica on the Shippensburg website. It'll take you to the page. But this is a nice version because it runs in your browser. You don't have to do any kind of installation. And it runs fairly quickly for the things that we're doing, because we're just going to be doing single commands at a time. If you ever had to do a lot of programming in Mathematica, you'd want to install the program itself on your machine. If you don't have Mathematica or don't have access to it, drawing graphs is actually something that there are lots of ways to do on the internet. And in fact, if you just open Google and ask it to plot a curve, Google has something built in that draws functions for you, and it draws functions in one variable and actually will draw things in 3 dimensions as well. And so that's very handy. You have to have nothing except Google on your phone or your tablet or your computer. And you can see it's the same picture, minus 8 to 4. This is a semicircle. So again, that's not really the issue. We're trying to find the area of the semicircle to answer the question. But my point is that you can draw it several different ways. So the area of this shaded region is 1/2 the area of the whole circle that would go all the way around. We know the formula for the area of a circle is pi r squared, and so we need to know what the r is. Notice that from here to here is 12 units, and so that's the diameter of the circle. So the radius of the circle is 6 in this case. So area of a circle, radius 6, and obviously that's different in different versions of the question. But you can see from the picture very quickly what the diameter of the circle is, and so half of that is the radius. So in this particular case, 1/2 the area of the circle, radius 6, would be 1/2 of pi times 6 squared. That's the area of a circle, radius 6, and that would be 18 pi.